Hi friends, welcome to the channel of Practicals. It has been a while since we last met. Hope all are doing great. Today I came up to introduce the new launch from Arduino family. Yes, the new Arduino UNO, called Arduino UNO Revision 4 or Arduino UNO R4. It is the last month that this board got released by Arduino. So I will explain all about this board that you need to know to start working on this. Before going to this video, please make sure to subscribe to this channel. This will be a great support to make more contents like this. Arduino UNO R4 is a successor to the popular Arduino UNO Revision 3. It was one of the most popular development boards at that time and is commonly used for embedded education and DIY electronics projects and also for small embedded applications. Unlike other development boards, Arduino UNO was a great platform for newcomers, and the Arduino IDE makes the hard part simple. But when it comes to embedded system development, developers mostly choose other boards like Arduino Nano or Mega, and also boards from other platforms. For example, ESP series from Expressive, STM boards from ST Microelectronics, Pico from Raspberry Pi, etc. Limited number of GPIOs was the main reason. Actually, Arduino doesn't develop any microcontroller chips. They normally uses chips from chip manufacturers like Atmel. The microcontroller chip that Arduino uses in the Arduino UNO R3 is the Mega 328P from Atmel. The Arduino UNO R3 has some significant flaws when compared to other development boards, such as small flash memory, minimum number of GPIOs, limited hardware communication peripherals like SPI, I2C, UART, etc. There is only single I2C and SPI ports, and UNO supports only two hardware-enabled UART communication. UART 1 in UNO needs to be software-enabled. UNO's relatively larger form factor is yet another drawback. The number of ADCs and their bit sizes are severely constrained. Pins that support PWM are also fewer. Additionally, the Mega 328P microcontroller processor in the UNO has a relatively limited clock frequency and only has 8 bits. Lack of wireless connectivity is also one of the serious drawbacks. But the newer version of UNO, the R4, solves some of these major issues, and additionally the CAN protocol is also included. This time Arduino introduces two hardwares under the UNO title, namely the UNO R4 Minima and the UNO R4 Wi-Fi. UNO R4 Minima can be considered as the direct successor to the UNO R3. UNO R4 Minima is armed with a powerful 32-bit microcontroller courtesy of Renesas. It maintains the same form factor, pinout, and 5-volt operating voltage as its predecessor, UNO R3. Minima have 256 KB of flash memory and 32 KB RAM memory. They have 14 digital I/O pins, 6 analog inputs, 1 DAC, 6 PWM pins, and also a 48 MHz clock frequency. It have single UART, I2C, SPI, and CAN communication port. Another important update is that UNO R4 uses USB-C port for programming. Like UNO R3, Minima also doesn't have any wireless connectivity. But UNO R4 Wi-Fi board is something different. It uses ESP32S3 chipset from Expressive for wireless connectivity. It have 384 KB ROM and 512 KB SRAM. Actually, we got two microcontroller chips in a single development board. This is actually interesting, isn't it? Because both of these chips are accessible and can be programmed separately. UNO R4 Wi-Fi board also include onboard LED matrix. This is a fully addressable 12 by 8 96-point red matrix that utilizes Charlie plexing to individually control each point. That is enough. Now let's examine the UNO R4 Wi-Fi board closely. When comparing with Arduino UNO R3, UNO R4 have some major benefits. In UNO R3, the microcontroller chip used is of Atmel's Mega 328P. But R4 comes with a completely new SoC from Renesas. The Renesas RA4M1 chipset is an ARM Cortex-M4 chipset. It is a 32-bit microcontroller which operates at an impressive 48 MHz clock frequency. This represents a substantial 3 to 16 times increase in processing power compared to the UNO R3. In addition, the Arduino UNO R4 benefits from a significantly expanded SRAM of 32 KB compared to 2 KB on the R3, and flash memory 256 KB versus 32 KB in R3, allowing us to create more feature-rich projects. The UNO R4 includes a 12-bit digital to analog converter, providing enhanced accuracy and precision for analog output. The analog-to-digital converter, which is the ADC, is also important. By default, the resolution is set to 10-bit, but it can be updated to both 12-bit and 14-bit resolutions for improved accuracy on analog readings. Another important thing is that UNO R4 is equipped with CAN protocol. CAN is known for its use in embedded systems. The CAN, Controller Area Network, bus allows you to minimize wiring and execute multiple tasks in parallel by connecting multiple shields. Along with an SPI port, this should enable more efficient communication between different components of a project. The majority of contemporary development boards include a HID, that is Human Interface Device capability, which the UNO R4 has built in, while earlier UNO models did not. You can use the keyboard or mouse API that is integrated into the core to convert your board into an HID. Last day, I have purchased one UNO R4 Wi-Fi board from Arduino online website. So let's take a look at it. The box contains UNO R4 and some user manuals. As we can see, the form factor is very similar to that of UNO R3. Same number of GPIOs and ADCs. But these pins are more capable than that of UNO R3, because the ADC resolution can be enhanced up to 14 bits, and UNO R4 also include a built-in DAC. UNO R4 Wi-Fi comes with ESP32S3 module wireless connectivity. Unlike the UNO R3, UNO R4 comes with a switched voltage regulator at the DC jack, which makes it possible to supply 6 to 24 volt through the jack. If you found this video interesting and useful, please make sure to subscribe to this channel. A complete video series of exploring the new features of the UNO R4 boards are on the way, so stay tuned.